Hi there, and welcome back to another one. We've made our way through all of the arrays and hashing, which is exciting. And I'm deciding which one to move into next. I'm feeling stack. I want to get through all these over the next few days, and I really want to see what a hard would look like. So to get started, we're going to go through with valid parentheses. So with this question, oh, you can't even see my screen. Whatever. I don't care. We're gonna go through valid parentheses. It's this one in the list because we've done all the arrays and hashing, and we're moving into stack. Okay. Oops. So we have a string S containing just the characters, parentheses, in and out, curly brackets, and square brackets. Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. So basically, it's like if we were to write like a code editing software like VS Code, this is what happens when they are this is like a feature that tells you if your code is within brackets. So our input would be something like this that rendered true, like, and then we'd have, you know, open close, open close, open close, true, and then open close of different types, false. So what we can do is, since we know that the string is given to us, we can create a map or a dictionary of each bracket. So we can say bracket map and make a dictionary of all the key value pairs that we're looking for. So for every bracket type, we want an open and closed to correspond with each type. And I'm not completely sure why we start with the closed before going to open, but we're going to take a look at that in a hot second. So we have a bracket map like this, and we have a stack array or stack list like this. And with the stack, I'm curious why like what is a stack? I don't know what that means. But what we're going to do is we're going to go through every character in this given string and look if that character is not in bracket map. We're going to append that character to the stack. And then we can keep going. Because what we're doing here is we're checking if we're checking if there's any duplicates in the bracket map. And if there's not, then we can append that character to the stack here. Then if not stack, or stack -1 is not equal to map C, we can return false. And this is really confusing to me. I'm not 100% sure what these lines do, but that's okay. What we're going to do next is we're going to say stack.pop, which means I believe it pushes a variable out. It pushes a variable out of stack, and it appends 1 to the beginning, I believe. I'll correct that if that's wrong, but we're gonna look. I'm just doing my best guess. Then from here we can return not stack. So we're returning the opposite of stack. Right? Is that correct? I'm not sure. I want to ask ChatGPT, and then I'm going to watch the NeetCode explanation. So we have a dictionary. We could explain that. That maps the closing brackets to their corresponding open brackets. I understand that. Then we create an empty list stack that will be used to store the opening brackets encountered while iterating through the input string S. So we have every character in S being iterated through, and if C is not a closing bracket, so if it's not this, because it's a key value pair as a closing bracket, we're going to go to the next string, or the next character of the string. But if it is a closing bracket, we can check if the stack is empty, or if the last element of the stack is not equal to the opening bracket corresponding to the current closing bracket. So the last element of the stack -1, so this deems it as the last element. Of the bracket map. If either condition is true, so if it's not stack, what does that mean? If not stack, or if stack -1 is not equal to bracket map C, which is the key value pair, or the value that returns from key value pair, it returns false. So if the input string has balanced brackets, we can pop the last element from the stack, basically removing it. Then after iterating through all the characters in the input string, we can check if the stack list is empty. And if it is, which is not, it's like if it's not empty or if it is empty, it returns a boolean, either indicating that the input string has balanced brackets, otherwise false, indicating the input string having unbalanced brackets. So this just tells us if it's unbalanced, but if it manages to get all the way through every character, then we know that everything has balanced brackets. Okay. So I'm going to watch the video because that was kind of confusing. I fully expected it to be confusing.
Hey everyone, welcome back, and let's write some more NeetCode today. Today, let's solve an easy problem, valid parentheses. This is such a common interview question. I think I've been asked this so many times, like in phone interviews and online assessments and stuff, so definitely a good problem to understand. We're given a string S containing only these 6 characters. They're basically parentheses type characters, right? Brackets, parentheses, closing, and there's 3 pairs, so there's an opening one, and then there's a closing one, and that's true for each of the 3 types, right? Open, and close. And if the open brackets are always closed by the same type of bracket, and if the brackets are closed in the correct order. So if that's true, then it's valid and we can return true. If it's not, then we can return false. So first example, now is this valid? Well, we start with an opening parenthesis and then we close it with a closing parenthesis. So it happened in the correct order, right? This was closed in the correct order. Every open has a matching close, so this is valid, so we can return true. Obviously, if the order was opposite like this, it would not, we would have to return false because first of all, this opening bracket isn't being closed, right? It's never being closed. It needs to, the closing needs to go on the other side of it. So other example, we see these 2 anymore because this is not valid, and the reason is the order is off, right?
That's what I thought.
That this closing parenthesis
I didn't
is
mention
actually
it,
being
but
applied to this open
I do
bracket,
believe.
but these
I didn't
do not
think that would
match
work.
each other, right? So these don't cancel out. So this doesn't work. Basically, the order is wrong, and that's pretty self-explanatory by looking at it, right? It just doesn't look right. So now how can we actually determine an algorithm to be able to solve this problem? Well, one of the first things you might notice is we have to start with an opening parenthesis. We can start with this, we can start with an opening bracket, or we can start with an opening curly bracket, but we can't start with a closing parenthesis, right? Because this is never going to be valid. We can't add any more stuff over here.
So it has to start.
Never going to make this valid, right?
It has to start
It's
open.
not being applied to any opening parenthesis. So we can't start with a closing parenthesis. We have to start with an opening parenthesis of any kind. And once we start with an opening parenthesis, we can pretty much add as many opening parentheses as we want as long as we're eventually closing them, right? So if we have 4 open parentheses, we have to have 4 closing that come after it. As we add a closing parenthesis that matches, right? So these 2 match each other, they counteract. We can then remove them from consideration, right? We can.
So I'm trying to figure out again why the key value pair starts with the closed and not the open.
Remove them from our list, right? So now let's say we get another opening parenthesis. We see it's being applied to this one, right? And we can remove these 2 as well, and we can keep doing that. So remove this and this and add one last closing parenthesis so we can remove it along with that, right? And once we're done removing that, if at the end we have an empty list, right, like this, let's say this is our list and it's empty, then we know we can return true because we closed all our opening parentheses, they matched each other, and everything went great. Also, notice how as we add closing parentheses, right, so this one, and then we have to remove from the beginning of our list, right? So now let's say we removed these, right? Now let's say we get a closing bracket. Okay, we got to remove it, and we have to remove this one. So we're always going to be removing from the end of the list, or the top of the list, or the top of the stack. So that's basically a hint for us that it's going to be helpful for us to use a stack data structure to solve this problem.
Yeah,
Because as
stack was so foreign to me
closing
going
a
into this. I
parenthesis,
wasn't
right. Let's say we add this
sure.
closing parenthesis. We're always going to be popping from the top. A closing parenthesis is always going to be matched to the most recent.
So we
opening
start with the
parenthesis.
close
and let's
and
say
move
we have
out
these
to
three
the
opening
open.
parentheses in a row. Let's say next we get this closing parenthesis. How do we know these two match each other? How do we know this closing parenthesis is able to close this one, right? How can we basically check? How do we basically match every closing parenthesis to the correct opening parenthesis like this, basically? And this closing bracket needs to match to the open bracket.
Yeah.
And the closing curly brace needs to match to the open curly brace, right?
Yes.
So I hope you guys can see what I'm doing up here.
So
this
we
is
start
basically going to be our hash map, actually.
with the
This
closed
is going to
and look for the
help
open.
us determine if a
So it's like
closing
look for here,
parenthesis
then look
matches an
for the open one.
parenthesis, right? Basically
Look for
just
the closed
correct
one on this
type,
side, and then look for
right?
the open one.
So let's say we had this closing parenthesis, right? We'd go up into our hash map and check, okay, this closing parenthesis matches this open parenthesis. Okay, well, what was at the top of our stack? This is at the top of our stack, right? This other closing parenthesis. So since they do match each other, we can cross them out. We can pop from the stack, right?
The concept of stack is still foreign.
Now let's say we get this closing parenthesis, right? Well, which one does this match to? We go up to our hash map and check, okay, it matches this one, right? This closing curly brace. Okay, let's take a look at the top of our stack. Hey, that's exactly what we needed, right? This closing is what's up here. So they do match each other. We can cross both of them out, right? And let's say lastly, we had a closing bracket. Okay, same process, check in our hash map. It matches this one. Is that what happens to be at the top of our stack? Yes, it is. So we can say these two match each other and remove them from our stack. And now let's say now we're done. Our stack is
so that's what that's what he means by going through the character array,
the parentheses matched
or
each other
the list
in the correct order, and we can return true now. So with that being said, let's jump into the code. And FYI, this algorithm is big O of n because we're only having to go through every input character once, right? We're just scanning through them. It is also going to take big O of n memory because we're using a stack. The stack could be up to the size of the input, which is n. So remember, we are using a data structure. The close to open parentheses, we're going to be using a hash closing parentheses to see, and I'm going to do that for all three types. So we had the closing and just going through is that means it's a closing parenthesis. And the reason why is because the keys, every key of this map is always a closing parenthesis. So if this is a closing parenthesis, we want to make sure that our stack is not empty, right? We cannot add a closing parenthesis to an empty stack, and we want to make sure that the value at the top of our stack is the matching opening parenthesis. So what
does he mean by stack?
Sure. So
like
the
top of the stack.
Python, stack of -1 is the last value that we just added in.
For C in close to open,
the stack, let's make sure that that is the.
For C in close to open, which is the character in. Oh no! If C in close to open, so C is the character. So if this close bracket is in close to open, then we look if stack and the top of the stack
matching open parenthesis that we need. We can get that
equals
by taking our map and getting the character.
It's starting to click, and it is within this character key value pair, like the close bracket. So if this is at the top of the stack, or if the closed, so we're looking for the open bracket in the given input string. And if it is in there, then we can look at the top of the stack. Or no, we compare the open bracket of close to open, and we look if it is if it's at the top of the stack.
Character from it, so we can basically, that's what we're doing. We're passing it.
And if stack, when they say if stack, It's like, is there stuff in stack?
In the closing curly brace,
I believe.
getting the opening curly brace or whatever where we need. If these match each other, that's good. That means we can pop from our stack and then continue going. If they don't match each other, or if the stack happens to be empty, that means we have to return false, because that means our parentheses don't match, right? Obviously, we know this is not a matching parenthesis. Having just a closing parenthesis to start us off is not matching. Also, this is not matching, right? Having a closing parenthesis with an open bracket, this is not matching. So that's why we would return false. Though if we So remember, at the end, once we've gone through every character, we can only return true if our stack is empty. So if not stack, then we can return true. Otherwise, we return false. So this is the solution code for this problem. I hope you
I get like 75% of it. It's a little fuzzy still, but I've found exposure to the new concept, which is what I'm looking for. And my syntax is not correct. All right, cool.